All right, so we're going to start factoring some things that are not just trinomials or not just perfect squares with a minus. But just so we know, a factorable polynomial with integer coefficients is factored completely when it is written as a product of things that you can't factor, okay, with integer coefficients. Meaning we don't want any fractions, right? So if I'm looking at part A, the first thing we always look for is a common factor. So these four are just kind of like a review of what we've already done. So if I look at this, my greatest common factor is x. So I'm going to divide an x out. X cubed divided by x is x squared. Negative 4x squared divided by x is negative 4x. And negative 5x divided by x is negative 5. So now I'm left with this trinomial, and I'm going to factor that. So I will leave the x out front, and I'm going to split this into two binomials. I look at the back, and I have a minus, which means a positive and a negative. To get that x squared, I would have to have x and x. And then I'm looking for two numbers that will multiply to make the 5 and subtract to make 4. That would be 5 and 1. But I want that 4 to be negative, so I'm going to put the 5 with the negative. That way it'll be negative 5 and a positive 1, which make negative 4. And then from here on out, we're just going to make sure we can't factor these two. We cannot. So I'm done. And just because I kind of want to lead into the next lessons, notice that this has a power of 1, this has a power of 1, and this is a power of 1. And if I add those up, that makes 3. I should not have any more than 3 factors at the most. All right? So on part B, I would look at this. I can divide both of those by 3, and I can also divide both of them by y to the third. Remember, you can always take out the smallest number of y's that you have. So 3y to the fifth divided by 3y to the third is y to the second. And negative 48y to the third divided by 3y to the third is negative 16. So now I only have 2 terms, and when I only have 2 terms, at this point all we know is that they need to be perfect squares with a minus sign if I want to be able to factor them. And I do have 2 perfect squares with a minus sign, so I will leave the 3y to the third out front, and I will factor that. Remember, when you factor the difference of 2 squares, you have a plus and a minus, and then I'm going to take the square root of that front number, which is y, that goes in front, and the square root of the number at the back, which is 4. And then I look to see if I can factor these two. I cannot. So I am done. And if we add up the degrees of each factor, this is 3, 1, and 1. That makes 5. So on part C, I notice that I have a common factor of 5, and I can also take out a z squared. So 5z to the fourth divided by 5z squared gives me z to the second. 30z cubed divided by 5z squared gives me 6z. And 45z squared divided by 5z squared gives me 9. So I have a trinomial. I'm going to try to split that into 2 binomials. Oops, that's not an x. I have a plus in the back. That means 2 of what's in the front. And then we have our z squared, so z times z. And then what multiplies to make 9 and adds to make 6? That would be 3 and 3. And under normal circumstances, I would probably write this as z plus 3, since I have 2 of them, squared. So I'm going to leave it like this for the time being. I can't factor any of those factors. And notice that I have a degree of 2, 1, and 1. That makes 4. All right, so on this last one, that's kind of a review. I can divide both of these by 5y to the fourth. So 5y to the sixth divided by 5y to the fourth is y to the second. And negative 125y to the fourth divided by 5y to the fourth is negative 25. And here I'm left with 2 perfect squares with a minus sign, so I can go ahead and factor that difference of two squares into two binomials, a plus and a minus. The square root of y squared is y, and the square root of 25 is 5, and I cannot factor that any further. And notice the 4, the 1, and the 1 add up to make 6. Okay, so now when we have two terms, we won't just be thinking about perfect squares, we're also going to be thinking about perfect cubes. So for instance, I know that 8 is a perfect cube because 2 times 2 times 2 is equal to 8, right? So if I were to ask you what the cubed root of 8 is, that would be 2. All right, so the number that you're going to be given, you're going to be given this part, okay? This is your answer, all right? So you have to identify the cubed root of each of the things that they give you. Now, let's say, for instance, that up here in front, there was an 8. Well, it's asking me what A is. A is the number that you cube to get 8. So if I said, okay, well, that's 2 cubed, then A is the 2, all right? And then I would just be plugging into this formula everywhere that I have an A. I get the B from doing the same exact thing. Now, I can have a plus, we call that the sum of 2 cubes, or I can have a minus, that would be the difference of 2 cubes. The formulas are exactly the same except for the signs. But this is, I'm going to kind of give you a little way to remember this, all right? The sign in the front parenthesis always matches the sign in your problem. So if I have a minus in my problem, then that first parenthesis will have a minus. If I have a plus, this one will have a plus. You always have two pluses and a minus sign, okay? And the one at the back is always a plus. So that means that if I have always two pluses and a minus, and there's always a plus at the back, and this one matches the plus, that means the middle has to be the minus, right? If I started with a minus, then the other two have to be the pluses. The A always goes in front, and the B always goes in back, which kind of makes sense, right? B for back. So this is just the A, the B. On this set, you have to square the A for the front, square the B for the back, and in the middle, you just multiply them, okay? So let's take a stab at these. You'll kind of see what I mean. All right, so first, I want to write these as perfect cubes. This one already has a cube, so I will just leave it as written. But I want to write 125 as a number to the third power. So how can I rewrite 125 using a cube? 5. It's 5 to the third. Now let's say you're not good at identifying that. Some of them are pretty easy to kind of pick out. You have a calculator for that, right? If you press the math button right underneath your green button, you get the math menu, and the cube option, cube root, is right here on option number 4. So if I press 4, see how I get the cube root, and I can just put in 125, and it tells me that it is 5. So I know that that would be 5 to the third power, okay? So that will kind of take the guesswork out of everything for you. If you ever need to do a different kind of root, like maybe a 4th root or 5th root, you would choose option 5. That way you can put your own number right there, just so you guys know. All right, so if I'm looking at this, I know that A is the number that's cubed in the front. So what is being cubed in the front? X. And what is being cubed at the back? 5. Now, do not say -5. That is already accounted for inside of your formula, okay? Then I'm just going to plug in. So I don't want you to reference the formula all the time. You just need to find ways to remember them, okay, without just sitting there and like trying to focus. I mean, kind of like think through them. So I know that the first one is just A and B, and the sign is going to match this sign right here. So A is X, so I have X, and then a minus sign, and then B is 5. All right, the second parenthesis, I know that I have to take my A and square it. So X squared is just X squared. And I already used the negative, so I know both of the ones over here will be positives. The middle, I'm just going to take and multiply the X and the 5. So if you multiply X and 5, you get 5X plus, and then you square the B at the back. So 5 squared is 25. Then I'm just going to ask myself, can I factor this trinomial? So is there anything that will multiply to make 25 and add to make 5? No. So we are done. That is the most I can factor this. And I will tell you that these rarely ever factor, but you know, the minute you don't check one, that's when you're going to have to factor. All right, now notice on this one we didn't have any common factor to take out, but if you look at part B, you really do. And here's a couple of things. Let's say that you always forget that you need to look for a common factor. A big hint that we're doing a bunch of factoring, but you can't factor an s to the 5th, that would tell you that, oh, you probably have a common factor, right? So if you look at these, the biggest thing that will go into both 16 and 54 is 2, and then I can take out an s squared. So if I divide that out, 16s to the 5th divided by 2s to the 2nd would give me 8s to the 3rd. And 54s squared divided by 2s squared would give me 27. Now if you look at these, you have two perfect cubes. So I'm kind of leave this s to the 2nd out there, 2s to the 2nd. Now this cube is only attached to the s. This is not 8 cubed. It's only s cubed. So you also have to write the 8 as a number cubed. So what number would I raise to the 3rd power to get 8? 2. So this would be saying the same thing as saying 2s to the 3rd power. And then what number do I have to raise to the 3rd power to get the 27? 3. So this would be 3 to the 3rd. So now let's identify what our A and B are. A is the thing that's being cubed in the front, which would be the 2s. And B is the thing that's being cubed at the back, so that would be 3. So I will leave the 2s squared up front, and now I'm going to plug into my formula. So I know the first one is going to be the A and the B with whatever sign this is. So I have a plus sign, so that's going to match right here. So I put the 2s in front, and I put the 3 at the back. Now listen carefully to me, because this is where people mess up all the time. I have to square my A, right? But that doesn't mean I just write 2s squared. I have to square both of these. So 2 squared is 4, and then s squared. All right? Since I know that my other plus sign, because I have 2 of them, is going to be at the back, this one has to be a minus sign. And then I'm going to multiply these two together. 2s times 3 is 6s. And then I have my other plus sign. And then I square the b. 3 squared is 9. And then if I was going to factor this, I would have to do the illegal move, right? 4 times 9 gives me 36. Is there anything that multiplies to make 36 and adds to make 6? No. So I am done factoring that one. So on part C, do we have any common factors? No. So this is already written with a cube. How do I write 64 as a number to the 3rd? It's 4 to the 3rd. All right? So that means that A is what? X. And B is 4. So I'm going to go ahead and plug in. The first one is always A and B, so X and 4. And then what kind of sign am I going to have? A minus sign. So if you have your minus sign here, that means the other ones are pluses, right? So I'm going to square my A. That would be X squared plus, multiply the two together. That gives you 4X plus square the B, 16. Is there anything that multiplies to make 16 and adds to make 4? No. So you're done. Now, on part D, I do have a common factor, but I also noticed that this front one, we don't want that to be negative, okay? So if at any point this first term is negative, you need to take that out, okay? So I'm going to take out a negative, but I'm also going to take out my common factor. Both of these will divide by 2x to the 2nd. So negative 16x to the 5th divided by negative 2x to the 2nd gives me 8x to the 3rd. And negative 250x squared divided by negative 2x squared gives me a positive 125. So now that I've taken out my common factor, I'm going to rewrite these as cubes, right? So if I want to write 8 with a cube, that would be 2x, both raised to the 3rd. And 125 is 5 to the 3rd. And you're going to end up using a lot of the same numbers, and then you just end up memorizing what their cubed roots are. So your A would be the thing that's being cubed in the front. That would be the 2x. Your B would be the thing being cubed at the back. That's the 5. And then we're going to go ahead and plug into our formula. Don't forget that you have that negative 2x squared right there. So in the front, I know I have 2x and then the 5. Now, I started off with a minus sign, but didn't I already handle that? I took it out. So really we're looking at this one where we've already written as our cubes. So I have a plus sign. That's going to match right here. And then you have a plus at the back, which means your first sign here is going to be the minus. So I'm going to square the 2x. That would give me 4x to the 2nd. And then my minus sign. Multiply the a and the b together. 5 times 2x is 10x plus square the b, 25. And if you were thinking about seeing if you could factor this, 4 times 25 is 100. Is there anything that multiplies to make 100 and adds to make 10? No, so I can't factor any further. All right, so sometimes we have more than 2 terms, more than 3 terms. Sometimes we have like 4 terms, all right? So in your mind, when you have 4 terms, you should think grouping, all right? 4 terms. That means you're going to factor by grouping, all right? So for some polynomials, you can factor by grouping your pairs of terms that have common monomial factors. So for instance, it's usually the first 2 and then the back 2. Not always. Okay, but usually that's the best route. So if I'm looking at this, do these 2 terms have a common factor? Yes, they both have a factor of x squared, right? And if I look at these 2 terms, they both have a factor of 4. So what I'm going to do is I'm going to group together the x cubed and the 5x squared. And then I'm always going to put a plus here. And then I will group together the back 2 terms. Don't forget to take that sign that's in front of your 4x, so the negative 4x minus 20. And what you're going to do is you're going to take out a common factor in both of them. So if I look at this parenthesis, I notice that my greatest common factor is x squared. So I'm going to take out an x squared. All right? So x to the 3rd divided by x squared is x. And 5x squared divided by x squared is 5. All right, then I notice that in this one, they're both negative. So let's go ahead and factor out a negative. And then the common factor is 4. So I'm factoring out a negative 4. Negative 4x divided by negative 4 is x. And negative 20 divided by negative 4 is 5. Do you notice anything interesting about each set? They both have what? An x plus 5. That is the goal. Okay? That's your goal. You want both of those to be the same, and here is why. If I think of this as one term, right? This is one term, and this is one term. What is their common factor? X plus 5. They both have an x plus 5, so I'm going to factor it out. So if I factor out the x plus 5, what does that leave me here? X squared. And if I factor the x plus 5 out of this term, that leaves me with negative 4. All right, I have now factored that. I'm going to look here and see I can factor this. Yes, that's 2 perfect squares with a minus sign. I can't do the x plus 5, but I can factor this back one. So I have a positive and a negative. Square root of x squared is x, and the square root of 4 is 2. Can I factor either of those? Nope. So I'm done. So essentially what happens right here is whatever they have in common, you literally write that down once, right? And then whatever's left over, that goes behind. All right, so if I look here, I'm going to look at the first two. Do I have a common factor between those two? Yes. Do I have a common factor between these two? Yes. So we will group together the first two, and we will group together the back two. Always putting a plus between the groups. Once I get those grouped, I'm going to take the common factor out. So common factor of these two would be x squared. So x cubed divided by x squared is x. And negative 2x squared divided by x squared is negative 2. All right, over here, your goal is to get the same thing, right? So, like, these were both positive, but these were both negative. So I needed to take a negative out, right? If you notice here, this is positive and this is negative, but this one's negative and this is positive. So I need to take out a negative. Greatest common factor is 9, so I'm taking out negative 9. So negative 9, x divided by negative 9 is x, and 18 divided by negative 9 is negative 2. See how they both have the x minus 2? So I'm going to put that in front, x minus 2. And that means I'm taking it from this one and I'm taking it from this one. So all I have left is x squared from up here, and then minus 9. Then I'm going to look to see if I can factor either of those. I can't factor the x minus 2, but the one at the back is 2 perfect squares with a minus sign, so I can split that into 2 binomials. So I would get x plus 3 and then x minus 3. And I can't factor those two, so I am done. All right, so do my first two have a common factor? Yes, they both have a y squared, right? Do the last two have a common factor? Yes. So I'm going to group together the 3y cubed and the y squared, put a plus sign, and then I have 9y plus 3. All right, so my greatest common factor in this first set is y squared. 3y cubed divided by y squared is 3y. And y squared divided by y squared is 1. I tell you, that's where everyone messes up. Make sure that you have that 1 there. Then I'm going to take out my common factor of 3. 9y divided by 3 is 3y. And 3 divided by 3 is 1. That was our goal, right? To have two of the same, so I'm going to factor out what's the same between them, which is the 3y plus 1. So essentially, knocking that out of here, knocking that out of here, and the leftover part would be the y squared plus 3. So I look at that. I don't have 2 perfect squares or 2 perfect cubes, right? So I'm done. So on letter D, I'm actually going to group something other than the first two together, just so you can kind of see how that operates. So if I were going to group two things together, I definitely like the 4x squared to be paired with the negative 4, right? Because they have 4 in common. And then I can put together the x cubed and the negative x. So I have x cubed minus x, and then I'm going to put the plus sign. And then I'm going to group together the 4x squared and the negative 4. So I just chose not the first two and not the last two. I grouped differently. So the greatest common factor here would be x, which would leave me with x squared minus 1. And my greatest common factor here would be a positive 4. So 4x squared divided by 4 is x squared. And 4 divided by 4 is 1. And then I see that they both have an x squared minus 1, so that's going to go in front. So I'm taking that off of this one and taking that off of this one, which leaves me with x plus 4. Then I'm going to look at both of those and decide if I can factor. These are two perfect squares with a minus sign, so I will factor those into two binomials. So the square root of x squared is x, the square root of 1 is 1, plus and a minus, and then I still have that x plus 4 at the back. And then I'm just going to make sure that I can't factor either of these. I cannot, so I am done. All right, so now we're just kind of throwing a bunch of different ones in here together. So if I look at part A, do I have a common factor there? 16 only divides by 2, 4, 8, and 16, right? And 81 only divides by 81, 9, and 3. So we don't have any common factors, right? But I do notice that these are both perfect squares, and I have a minus sign. So I'm going to go ahead and factor that into 2, plus and a minus. The square root of 16x to the fourth would be 4x to the second. So that goes in the front. And the square root of 81 would be 9. Then I have to look at both of those and decide if I can factor either of those. So can we factor either of those? Yes. Which one? The last one. I can't do this one because it has a plus. We can only do pluses when they're cubes, right? So I will leave the 4x squared plus 9 alone. And I'm going to take the square root of the 4x squared, which would be 2x plus and 2x minus. And then the square root of 9 is 3. And then I would look again to see if I could factor those. I cannot. So I'm done. All right, so if we look at part B, common factor, we can factor out a 3 and a p squared. So 3p to the 8th divided by 3p squared would be p to the 6th. 15p to the 5th divided by 3p squared would give me 5p to the 3rd. And 18p squared divided by 3p squared is 6. Now we haven't factored a trinomial that has a bigger power. I think we may have done maybe one that had a fourth. But as long as this power is half of this one and you don't have a variable back here, then you can factor them just like normal. So I've got a plus in the back. That's 2 of what's in the front. And then to get p to the 6th, I would just need p to the 3rd times p to the 3rd. And honestly, it should be whatever this is. All right? And then what multiplies to make 6 and adds to make 5 would be 3 and 2. And then I would look at those. P cubed is a perfect cube, but 3 is not, right? Same thing here. So I am done. So if this would have been like p to the 8th with a p to the 4th, that would be fine. Or a p to the 10th with a p to the 5th, that would be fine. As long as that middle one is half of what your beginning one was. All right. So on part C, I don't have a common factor here, but I don't want that to be negative out front. So I'm going to take the negative and factor it out. So that leaves me with a positive 16 into the 4th and a negative 625. And if I'm looking at these two numbers, both of them are perfect squares. So I know that I can factor this into two binomials because I've got a minus sign there. So that gives me plus and a minus. The square root of 16 into the 4th is 4n squared. and the square root of 625 is 25. Then I'm going to ask myself, can I factor either of those? So can we factor either of those? Just the one at the back. We can't do this one because it's perfect squares and you have to have a minus sign. So we'll leave the front one alone. I've got plus and a minus. The square root of 4n squared is 2n, and the square root of 25 is 5. Can you factor either of those? Nope. So we're done. Typically, when you have two terms left, right, you can't factor anything out if it doesn't have even a power up there, right? All right, so greatest common factor back here, I can divide all those by 5 and a w squared. So 5w to the 6th divided by 5w squared is w to the 4th. Negative 25w to the 4th divided by 5w squared would be negative 5w squared. And 30w squared divided by 5w squared is 6. So if I'm looking at this, I've got a 4. This is half of 4, right? And then I don't have a variable, so I can go ahead and factor that. We'll have two minus signs, w squared and w squared. And what multiplies makes 6 and adds make 5? 3 and 2. And neither of these are two perfect squares, or cubes. So I'm done there. All right, so this is going to be almost like a throwback to division. All right, so here's the thing. Let's say I said, okay, tell me if 6 is a factor of 30. Is 6 a factor of 30? How could you prove that to me, though? Okay, but you can't use 5. You have to prove to me that 6 is a factor of 30. Wouldn't you just take 30 and divide it by 6? 6 doesn't go into 3. 6 goes into 30 5 times. That gives you a remainder of 0, correct? You have just proven to me that 6 is, in fact, a factor of 30 because you got a remainder of 0. The same applies to when you're talking about polynomial factors. If this divides evenly into this, then it means it's a factor, right? So when I divide them, I'm looking for a remainder of 0. Now, what's the easiest way for me to divide this? Using synthetic division, right? So what's the number that has to go outside the box? 2, because remember, you would set that equal to 0 and solve. Are you missing any terms over here in what you're dividing? So I have a 1, a 2, and a negative 4. And what am I looking for? A remainder of 0. So I'm going to drop the 1. 1 times 2 is 2, plus the 2 gives me 4 times 2 is 8, plus the negative 4 is 4. Is this a factor? No. And you may want to put out to the side in your notes why you said no, because if you look back, you might be like, well, why did we choose that? You need to just put remainder was not 0. Okay? So if we look at part B, what number goes on the outside? Negative 5. Are we missing any terms? We're missing the x, right? So we have 3, 15, negative 1, 0, 25. So we drop the 3. 3 times negative 5 is negative 15. Plus 15 gives me 0. 0 times negative 5 is 0. Plus a negative 1 is negative 1. Times negative 5 is 5. Plus 0 is 5. Times negative 5 is negative 25, which gives me a remainder of 0. So is x plus 5 a factor? Yes. And you might want to write out there in your notes because we have a remainder of 0.